Alright, so this is 4.3 right triangle trigonometry. So our objectives is construct and compare linear, quadratic, and exponential models to solve problems, and then interpret functions in terms of situations they model. Our central questions is how can right triangle trigonometry be used in construction, and how can we find the angle if we know the value of a trig function? Those are some of my favorite problems. So, sine theta equals the length of your opposite over your hypotenuse. So when you think about a right triangle, you have your opposite side. So if I'm looking at sine theta, I have my opposite side over my hypotenuse, the value of A over C. Cosine is the value of B over C, so it's the adjacent side. And tangent is A over B. One of the ways that I was always taught to remember this is sine is opposite hypotenuse, cosine is adjacent and hypotenuse, and tangent is opposite and adjacent. So SOHCAHTOA. I still think of that when I have to think of these. So secant is your opposites. So you have C over A, C over B, and B over A. So you're just flipping the previous ones. So let's look at an example. Find the value of the 6 trig functions in the figure. First thing you want to do is work on finding C. So use your Pythagorean theorem. So you have a squared plus b squared equals c squared. So 3 squared plus 4 squared equals c squared. So now you know A is 3, B equals 4, and C equals 5. So sine of theta, cosine theta, and tangent theta. Sine of theta is your opposite side, so your A, over your hypotenuse, which is C. So 3 over 5. Cosine is your adjacent, so B over your hypotenuse, so 4 over 5. Tangent is your opposite over your adjacent, so 3 over 4. Now you have cosecant, secant, and cotangent. These are all going to be the opposite of your previous one. So now you have 5 over 3, 5 over 4, and 4 over 3. And that's all you have to do for those. So in this case, you're given that you have 45 degrees. So right triangle with a 45-degree angle, or pi over 4 radian angle, is isosceles. So that means it has 2 sides of equal length. A right triangle that has 30 degrees, or pi over 6 radian, also has a 60 degree, or pi over 3. So you have 30, 60, 90 triangle. And the measure of the opposite side of the 30-degree angles is half the measure of your hypotenuse. So let's look at an example. So it's telling you that you have a 45 degrees, so you know that it's 1, 1, and square root of 2. So we're going to have length of the hypotenuse, which is square root of 2, and length of the opposite is 1. So your answer is just square root 2. Your secant, your length of your hypotenuse is square root of 2 over 1, so again, you just have square root of 2. Cotangent is you want the side opposite, or the side adjacent, which is square root, which is 1, and your side opposite, which is also 1. So your answer will be 1. Use the figure to find tangent of 60 and tangent of 30. So in this case, you want to think tangent of 60. So here's my 60. You want the side opposite 60, which is square root of 3, and then the side adjacent, which is 1. So it's just square root of 3. Tangent of 30, you want the side opposite, so 1, and then the adjacent, which is square root 3. You can't have square root in the denominator, so you have square root of 3 over 3 as your answer. Here are some trig functions that you should remember. I would copy these down again. So you have sine theta. If it's 30 degrees, it's going to be 1/2. If it's 45, it's square root of 2 over 2. And it's 60, it's square root of 3 over 2. Write these ones down. And then you want to complete the problems below. And we'll watch the next video about complements and applied problems.